All right. Well, good day, everybody. Okay, so here we go. These are the notes for worksheet 9L, which we're going to learn how to evaluate logs with the calculator, and we're also going to learn about the change of base formula with logs. If you look at your calculator, you'll notice that there's a couple buttons that have logs, but there's not an infinite number of buttons that have logs. So we can't really use a log with base 2 and also base 3 and also base 4 and also base 5. Like, we can't have a button for each of those, or our calculator would be like impossible to hold. Anyway, we'll learn about that formula in just a bit. So let's warm up our brains at first. If we are looking at this problem here, 4 to the x equals 8, what I am looking for is, can they have a same base? So can I rewrite them as 2 to the something? Yeah, I think I can. So let's see here. The 4, that's the same as 2 squared. Raised to the power of x, and 8 is the same as 2 to the third. And so that is going to give me a 2x equals a 3, and so therefore x is 3/2. So yay, I was able to solve this problem just using my exponent properties. Now, this next problem is a little bit different. And the reason that this is a little bit different is because I don't know how to rewrite a 15 as 2 to the something or as 4 to the something. And so while I can estimate what x is, I could say, let's see here. If I need to make a 4 become a 15, I guess if x was equal to 2, I would get a 16. So x has to be less than 2, but it has to be greater than 1. Okay, I can at least start to estimate that. But to get the exact value, what I'm going to end up needing to do is I'm going to end up needing to use logs. All right, and so that's our goal. That's one of our goals for today. So here's a picture of the calculator. Hopefully you can pull out your calculator. What you're going to see here is that there are 2 different buttons. This is my, first button that I want you to recognize. That is a log that is base 10. That is actually called our common log. All right, that should sound familiar, but that's our log base 10 button. And then our second button of interest is the LN button. That is log base E. So, it's basically log base E, but instead of writing it that way, we write it as LN. And that is log naturel, or, the natural log. Natural log. So those are the only 2 that get their own buttons, because basically any log can just be rewritten in terms of those. Now, evaluate each of the following logs using your calculator. So for these problems here, problems 1 through 4, you're literally just punching buttons on your calculator and just making sure that you know how to use these buttons. So let's see here, 3 ln 6. So if I go to the calculator, I've got 3 natural log of 6, close the parentheses, and at 5.375. So, there's my result there. All right, it's pretty straightforward. So let's see, why don't you get out your calculator? I'm going to pull out another one here, and let's try this on your own. Make sure you're just trying this out, making sure that all the settings and everything you do on your calculator are working correctly. So for number 2, I get negative 0.903. For number 3, let's see, natural log of 4 plus natural log of 5, 7. and log of -7. Uh-oh. Wait a second. I think this is going to give me an error, right? Because basically, remember, this is a base 10. So this question is essentially asking what exponent, because remember, a log is just a missing exponent. What exponent is going to turn a 10 into a -7? Well, nothing. There is no exponent that could possibly turn a 10 into a -7. So this is not possible. This is a no solution. And that's why your calculator gives you an error. All right, so you are asked to solve for x and it's right in the middle of like an equation and there's some logs, sometimes it's really not that big of a deal. Sometimes you might have to like get that x out of the log. So for this first problem right here, problem number 1, what I first want you to recognize is here's my log. But log 18, heck, that's just a number. I can plug that into my I'm going to do that right now. Log of 18 is 1.255. So this is 1.255 minus 2x equals 5. Oh my goodness, this is really not that hard of an algebraic problem. I'm going to subtract my 1.255 over here. So negative 2x is going to equal 3.745. 3.745, and then I'm going to divide by -2, and there's my answer. So this one was really pretty straightforward because the log was just a log of 18. So in this case, I get divided by 2, negative 1.872. All right, so we like those problems. Those are pretty easy. Now, this next problem, notice that this next problem is different. The variable is in the log. So the variable, they don't fit, is in the log. So if it's in the log, then I'm going to have to rewrite this as an exponent in order to solve it. So this right now is a log of base 10. And so I'm going to take this and I'm going to rewrite it. Rewrite as an exponent. Remember, a log is just an exponent problem. So this here is base 10 to the power of 7.5 will be equal to x. And then we can put that into our calculator, or you know what, that's going to be such a ginormous number, I'm just going to call that done and say that x is equal to 10 to the power of 7.5. All right, so now let's continue to do some solving. We have to where is our variable? So right here at this first problem, I have natural log. So here's what I like to do sometimes. I like to just throw that e in there. You're welcome to do that. There's nothing wrong with doing that. This is base e. That's what I have a very basic, right here. This is my base. This is my exponent. And this right here is my result. All right, so we're just rewriting it. So when I rewrite it in its other form, it's going to be e to the power of 3.8 will equal x plus 2. So I simply took the 3 parts of a log, rewrote them as an exponent, and now this is what I can do in my calculator. So just subtract 2 over, and so what do I have here? I have that e to the power of 3.8, and then subtract 2 is what my x value is. So let me get my calculator out. E to the 3.8, take away 2 is, let's see, e to the power of 3.8. take away 2 is 42.7. So x is 42.7. Ooh, sorry guys. So now, right here, here's my variable. I have found x. Found it, there it is. But it's in the exponent. So the only way to get it out is to log it out. So what I want to do is maybe rewrite this as a log. Ooh, sorry guys. All right, so when I rewrite this as a log, here it is. I've got base 10. So it's going to be log, common log, base 10. And a log is an exponent. So the exponent of 2x goes over here, and the 0.57 goes here. And now I have something that I can do with my calculator, right? This I can evaluate in my calculator. So log of 0.57. Let's see here. Log of 0.57 is negative 0.244. So negative 0.244 is equal to 2x, and then divide by 2, and we will be able to find out that x is negative 0.122. Okie dokes. Now, in our last one here, let's see. There's 2 letters. Oh my gosh, there's 2 variables. Actually, no, there's not, because remember E is E. E is 2.718. Now, if we want to rewrite this as a log, we have to be careful, because here's our base. This has base E. And so that means we're going to use natural log. So if I'm going to rewrite this as a natural log, here's my 3 pieces, and I'm going to read its natural log form. So natural log, right, log base E, of something equals something. Well, a log is an exponent, so the exponent goes here. And so the 12.5 goes here. The log of 12.5, 2 minus x. And we can do this in our calculator, right? This is something we can put into our calculator. Natural log of 12.5. So let's see here. Natural log of 12.5 is 2.52, how about 2.53? So 2.53 is equal to 3 minus x. And let's see, subtract my 3 over. So negative 0.47. Negative 0.47 is equal to negative x. Divided by negative 1 on both sides. So x is positive 0.47. And there you go. We have just solved for x. Okay. Now, suppose we are given this problem, and we kind of saw one like this in the warm-up. And, can we solve for x without a calculator? Well, I'm thinking, okay, 2 squared is 4. 2 to the third is 8. So I need 2 to the something to equal 7. Well, it's going to be somewhere in between here. So I'm thinking that x is, probably like, I don't know, 2.5 2 point, I don't know, 2 point something. I'm thinking maybe it's closer to the 8 than it is to the 4, so I'm guessing it's approximately 2.8-ish. That is purely a guess, but it's an educated guess. Now, there's our approximate value. Whoop. Without a calculator, all I can do is get an approximate value. But if I take this and I rewrite it as a log, then I can actually use my calculator. So if I've got 2 to the power of x and it equals 7, what I can do is I can either rewrite this as a log, and if I rewrite it as a log, I'm looking at, the 3 different pieces. All right, here's my 3 different pieces. The base is a 2, so I would have log base 2 of something equals something. Well, a log is an exponent, so the exponent goes over here, right? Here's my log on the left side. Here, my is the equal sign, okay? A log is an exponent, so by default, the 7 goes there. So here's what I have. I have that x is equal to log base 2 of 7. And, honestly, some of our newer calculators allow us to do this. But if you look at your calculator, you don't have a button for base 2. There is no button for this. And so you might feel stuck. And so we want to show you maybe an alternative approach to this. So if I have 2 to the power of x is equal to 7, an alternative approach would be to just take of both sides. It doesn't really matter what log we use. So natural log this side, natural log that side. Okay, so now we can use our log properties and we can say, oh look, this exponent can now come out front. So I've got x is multiplied by natural log of 2 and it equals natural log of 7. And if I want to solve for x, I'm going to go ahead and divide by the natural log of 2. And so here's what I get. I get that x is equal to the natural log of 7 divided by the natural log of 2. And of course I can go and I can plug that into my calculator. Natural log 7 divided by natural log 2. So let's see. Natural log of 7 and the parentheses divided by natural log of 2 and the parentheses. And I'm going to get 2.81. So x is approximately 2.81. Wow, that was a pretty good guess. I guessed earlier it was 2.8. I'm patting myself on the back. Okay, so now what we just did, I want you to kind of look at these 2 methods. I'm going to grab my little highlighter here. Here's what I want you to notice. This right there, it goes here, and this right there goes here. And what I have sort of just proven to you is that this relationship between these 2 logs is our change of base relationship. Change of base. I essentially solved this problem an alternative way where I used base e. Whereas, I kind of got stuck in the first way that I did it because I had a base 2 and I didn't have a button for that. And so if you find yourself stuck in that way, you can just approach it in a different way and solve it with a different base. Here is our change of base formula. Basically, any log base, any b value, and any a value can basically, each of these letters gets their own log. So see here, the B gets its own log, and the A gets its own log. And then we divide those logs, okay? So that was just like the example that we did with the 2 and the 7. I will typically always use the natural log, but you could honestly use any log base. So for this first problem, here's what we're going to do. This is actually exactly the same as 2 logs getting divided. All right, the log of the 1/2 goes on the bottom. The log of the 5 goes on the top. Or you could do the natural log of the 5 on the top and the natural log of the 1/2 on the bottom. And honestly, both of these are going to give you the exact same answer. Okay, try it. Try it on your calculator. Try it both ways on your calculator. It'll give you the exact same answer. So let's see here. Natural log 5 divided by natural log of 0.5. And I'm going to get negative 2.32. So for this next one, it would essentially be 2 logs getting divided. The base always goes to the bottom. Base, bottom. They both start with B. All right, so natural log 4 on the bottom and natural log 0.025 on the top. All right, try that one in your calculator. We're going to get natural log 0.025 divided by natural log of 4, and I get negative 2.66. So make sure you're trying that out in your calculator and you're getting the same answers, just so that you know you're kind of inputting it the right way. All right, so now you're going to just see a mix of problems where you can really kind of use any of the tools that we've given you so far. When I look at number 1, the first thing I notice is the 4 and the 8. I notice that these guys share a base of 2. So I can literally just rewrite this problem with 2 as something, and I keep this as an exponent problem that I'm going to solve. So this right here, that is going to be the same as 2 squared, but it's 2 squared raised to the power of x. And then this right here is the same as 8 to the 1/2. But then I'm going to rewrite that 8 as a 2 to the 3rd to the 1/2. And so now I can just take this and this, and I will be able to say that 2x is equal to 3/2. And so x will be 3/4. All right, that's sort of an ideal problem, right? You share the same base, you don't even need logs. But when I come over to problem number 2, these do not share the same base, so I have to use logs here. And you can either rewrite this as a log, or you could just log both sides. It might be easiest just to log both sides. So I'm going to do natural log of, 6 to the x minus 5 is equal to natural log of 25. So I just logged both sides. But now I have a log property where it's like, oh, wait, hey, I can take an exponent and bring it out front. So now I have an x minus 5 is essentially getting multiplied by a natural log of 6. Okay, let me put a little bracket situation around that x minus 5. And that is equal to natural log of 25. Okay, so now I want to solve for x. So I'm just going to maybe reduce this side by natural log 6. All right, so now I'm going to have x minus 5 is equal to, and I can go ahead and punch this thing into my calculator, figure out what that is. Natural log of 25, natural log of 25 divided by natural log of 6 is 1.796. How about we call that 1.8? So 1.8. And then we just add our 5 over, and so x is 6.8. All right, so that is one way to deal with a variable that's in the exponent. All right, number 4, let's see, my variable is also in the exponent. So I'm probably going to want to like get that out using logs. Gosh, I think I might actually start by reducing both sides by 2, just because I can. So now it's a simpler equation. E to the 4x is equal to 8. And if I want to log both sides, I will definitely use natural log in this scenario. So I'm going to natural log this and natural log this. So here's what I have. The natural log of e to the 4x is equal to the natural log of 8. Now, this 4x can come out to the front. So I've got a 4x multiplied by the natural log of e, and it equals the natural log of 8. Hey, wait a second. Natural log of e, that's just a 1. So this is really a 4x getting multiplied by a 1. That's why I chose natural log for this problem. Equals natural log of 8. And so I think now I basically would just divide by 4 and divide by 4. So x is going to be the natural log of 8, and then that answer gets divided by 4, not just the 8. It's not the 8 that's getting divided by 4. The 8 is actually attached to the natural log. So the natural log of 8 2. So x is 0.52. All right, and our last problem here, very similar. Wow, surprisingly similar. Okay, let's maybe start the same way. How about we divide both sides by a -2? So then we've got e to the 4x is equal to -8. Now, let's think about this for a second. Wouldn't this be, it's sort of equivalent to 2.7-ish, all right, a 2.7-ish number raised to some exponent is going to become a -8. I'm really hoping that you see this and you go, oh, wait a second, that's not possible. Because I can't take a positive base number, multiply it by itself over and over and over, and somehow magically turn it into a negative number. That's not going to happen. So there is no answer here. So there you go. That's some stuff to expect with logs. You've seen me rewriting exponential equations in terms of logs in a couple different ways. So let's apply these properties to some basic true-false questions. Is the first statement true or false? Log base 2 of 3 is equal to 3 over 2. Well, I think, let's see here. There's definitely something about the 2 going to the bottom and the 3 going to the top. That seems familiar. But you know what? This one's false. It's really familiar, though. But what would make it true would be if log base 2 of 3 equaled natural log of 3 divided by natural log of 2. So if this number goes to the bottom and this number goes to the top, but they each have their own logs, then that's fine. That is the change of base formula. All right, now for this next one, true or false? Log 3 minus log 2 is equal to log 3 over 2. Ooh, that's going back to our properties. So let's see here. Let's condense this. Condense it. And when we condense it, I do believe we can bring those two logs together. And the 3 and the 2 will actually divide. And so, yes, they are the same. So that's great. This is true. So that's how you want to approach these, is maybe use your expanding, condensing properties or your change of base properties to see if you can change one side to look like the other. All right, so that is your lesson for 9L. Hopefully you feel empowered to do your homework, maybe start it tonight and finish it up in class. All right, thanks. Bye.